Hi everyone, and today we're going to talk about expected value. We're going to take a probability and apply it to this really important concept, one of my favorite concepts, expected value. What do I expect to happen when I do something? Now, this is largely related to profitability, random chance. Am I expected to win or lose when playing a game? So we're going to start with our warm-up. A bag contains 4 balls, 3 orange ones, and a green one. You pick a ball, record your selection, and then you replace it. You do this 4 times. What's the probability that out of the 4 picks, you get 0 greens, or 1 green, or 2 greens, or 3 greens, or 4 greens? Pause this video, try it out, and see if you can get all those probabilities. And remember, this is the probability distribution, so they should all add up to one whole. Now, before I go over the answer, if you're still wondering how to do this, okay, try binomial probability. It's with replacements, so they're independent trials, and we're doing 4 of them. So try binomial probability for a few of these. Okay, we're going to look, and we have some probabilities. Now, it's most likely that I pick exactly 1 green ball out of my 4 picks. 0 and 2 are pretty high probabilities, 21% chance or 32-ish% chance. Really unlikely that I pick the green ball every single pick. And this was our binomial probability. I showed the example for picking 0 greens. Now today we're going to take that and apply it to expected value, which is a prediction given all the possible outcomes, all their probabilities, takes in some weighted averages. So we're going to look at some examples today and we're going to explore. So let's start with this. We're going to play a game. You get the opportunity to roll a fair 6-sided die. And here's how the game works. If you roll a 1 or a 2, you win $15. If you roll a 3 or a 4, you win $20. And if you roll a 5 or a 6, you lose $30. Do you want to play this game? Now, I want you to think about what are the pros, what are the cons of this game so far? What do we know? So one of the pros is there's 4 ways to win. I win if I get a 1, 2, 3, or 4, and there's only 2 ways to lose. A con is I can lose 30, but I can never win more than 20. And sometimes I only win 15. Now today we're going to learn about expected value and is this a game we want to play? On average, does it have a positive outcome or does it have a negative outcome? This is what we have to think about when making decisions based on probability. Do I win more than I lose? So let's look at some employee hourly wages, find the averages of them, look at probability, and we're going to connect that to expected value. So looking at this graph, what's the probability that an employee makes $12 per hour, $25 an hour, $50 an hour? And then what's the mean? What's the average hourly wage? So I see 14 out of the total 20 make $12 an hour. 5 out of 20 make $25 an hour. 1 out of 20 makes $50 an hour. Probably the boss. And we've learned how to find the mean, the average. We add them all up. So we have 14 people making $12 and 5 people making 25 and 1 person making 50. We divide that by 20. We get the average employee makes $15.90. Now, there's no single employee that makes $15.90. In fact, most of the employees make less than that. But the average, the expected value of an employee is to make $15.90 at this company. And that's what expected value is. It's the average outcome that will occur with many trials. Okay, it's going to take into account the outcome and the probability of that outcome. So this is the formula that we're going to use. E of x stands for the expected value. X1, X2, X3, all the way up to Xn. Those are all the different outcomes, and you multiply each outcome by its probability. So today we're going to need to know what outcomes are possible, what the probabilities are of the outcomes, and then we're going to add them after we multiply. So it's the average outcome when conducting many trials. It's not what's going to happen in any single trial, but what can I expect to do if I do 100 trials? What should each trial be approximately? So we're going to look at this spinner game. Okay, Carnival's got the following game. You pay $1 to spin the wheel 3 times. If you spin even, and then even, and then even, 3 evens in a row, you win $4. Otherwise, you lose your original $1 and you get to try again later if you want to pay another $1. So how much money are you expected to win or lose from this game? Now, when we're looking at expected value, we first need to figure out what our outcomes are. So in this case, I can win. Now, I only win a net of $3 because I win $4, I paid $1, so I gain $3. I have $3 more in my pocket if I win. And if I lose, I just lose $1. Okay, I lose the original $1 I paid, and that's it. Then I need to know the probability of winning and the probability of losing. So to win, I need to spin an even, and an even, and an even, and these are independent events. So there's a half chance I spin the first even, half the second, and half the third. There's a 1/8 probability that I win. Now losing is the complement here. So I can take 1 minus 1/8 and get 7/8. So now I have an event and the probability, and another event and the probability, so I can do expected value. So the event was win 3, and it happens 1/8 of the time. Another event was lose 1, happens 7/8 of the time. And if we add them together, we get negative 5/8. Now, you can have a negative expected value. What that means is you lose 5/8 of a dollar or 63 cents every time you play. Now, you can't lose 63 cents, but that's the average expected outcome. So each time I play, I should expect to lose money. There's going to be some cases where I win, but a lot more where I lose, and the losses are going to overtake the wins. So the expected value that's negative probably means it's a bad game for me to play. So let's look at some more expected values. The expected value when rolling a fair 6-sided die. Now, as we go through the rest of this lesson, if you want to pause and try out these before I show answers, go for it. Show yourself that you know how to do it. So in this case, I got 6 events. I could roll a 1, I'd have a 1/6 chance of that, or a 2, and a 3, and a 4, and a 5, and a 6, and I have 1/6 chance of all of them. So I can have a lot of outcomes. Well, a lot of different probabilities. In this case, all the probabilities are the same because it's a fair die. So the average expected outcome is 3.5. It's between 3 and 4. Okay, if I roll 2 dice, the expected value is 7. 3.5 on each die. 3.5 plus 3.5 is 7. That's why 7s are the most commonly rolled number on 2 dice. Now, the second one, a website which tracks weather in Minnesota reports that snow on any given day in January is approximately 26%. How many snowy days should we expect in Minnesota in January? So we take the 31 days in January. Please make sure that you put 31, not 30. And there's 26% chance per day. So each day there's 26% chance. So approximately 8 snowy days in January, which is reasonable. We know that. Okay, we live in Minnesota. Now let's go back to our dice game that we started with, where we said, hey, is it a good game or a bad game? We don't know yet, but we have some ideas. Find the expected value of a single roll. So in this case, you have 3 different outcomes. And you have, in this case, it happens to be the same probability because there's a 1/3 probability you roll a 1 or a 2. If you roll a 1 or 2, you get win 15. Okay, you get win 20 and lose 30. So we have 3 outcomes, 3 probabilities. Now we got to take multiply and add. We have to remember, though, if an outcome is negative, we can put a negative sign in. So this is negative 30. Positive 20, positive 15. Positive generally means I win. Negative means I lose money. And I wind up with 5/3 or 1.67, which means I win $1.67. I would play this game every day. Yeah, there are cases where I definitely will lose $30, but there's a lot more times where I win 15 or 20. So it makes sense for me to play the game a lot of times, and over a long series of trials, I should start winning $1.67 every roll. Now, we should also take into account other real world examples like car insurance. Okay, a lot of times you have something called a deductible and a premium, where if you pay the premium, you get the insurance, and then if you get in an accident, you got to pay the deductible. So some policies like C are cheaper, but if you get into an accident, then it becomes much more expensive. If I get into an accident, then the policy C costs $902, where A, I'm paying the most upfront, but even if I get into an accident, I'm only ever paying $480. I don't have to pay extra for if I get into an accident. So which option has the least expected cost if there's a 10% chance of needing repair annually? So you get into an accident 10% of the time. So what we can do with this is we can look and find the expected value for each one of them, and then we should pick out the best policy or what is the cheapest expected policy. So if you want to try this, pause it, go ahead, try finding expected value for each situation. Okay, let's take a look at some of these expected values. So case A, there's a 90% chance I'm going to have to pay $480. And there's a 10% chance I also have to pay $480 because if I get into an accident, I don't have to pay anything additional. Policy A is going to cost me $480 no matter whether I get an accident or not an accident. Now, B and C are different because there's 90% chance I don't get into an accident and don't have to pay the deductible. There's a 10% chance I have to pay the premium and the deductible. So $447 plus $200. So policy B is looking pretty good, and policy C looks even better. Because most of the time, I'm not paying $902, I'm paying $402. If these percents change, then a different option will probably be better. So depending on how careful of a driver I am, okay, I might want to pick the low premium if I'm pretty sure I don't get into an accident. If I've been in some accidents before, I may want to pick the higher premium with the lower deductible, just in case I get into an accident. Option C in this case is the cheapest. Now, what if the percent chance of needing the repair was different? What happens if it was 17%? Go ahead and calculate the expected values, and let's see, does the option change? Do I want to pick a different plan instead of C? Or at 17% is C still the best? Okay, let's see how you did. Now option A is better. From changing it from 10% to 17%, C went from the best option to now the worst option. So we need to take these factors into account when making decisions. A slight change of probability changes what decision we want to do based on the expected value. Now you could still pick option A, and many people still do. You could pick C, you could pick B. You're allowed to pick any choice you want, but you should use expected value to think what might be the best in this situation. And we're going to finish with one last example that includes binomial probability and it includes expected value, a carnival game. 3 orange lights and 1 green light that flash rapidly, and the order is random. You push the button. If it's green, you win. You're going to play this game 4 times. How many prizes should you expect to win? So if we use binomial probability, we can find the probability, like we did in the warm-up, of winning 0 prizes all the way up to 4. And these 5 numbers add up to 100%, because those are the only things that can happen. And I take the event, which is win 0 prizes, multiply by the probability of it, and do that for all of them. So you're expected to win 1.001 or just 1 prize, which should make sense because you're going to play the game 4 times and you win 1/4 of them. So 1/4 of 4 is 1. So expected value uses what we know, takes an event and multiplies by its probability to weight it towards what's most likely. So now we have the ability to use expected value to make decisions with probability. And that's what we're going to do in our final lesson next time. We're going to make decisions.